So we're going to work on the graph of the secant, cosecant, tangent, and cotangent. Starting out with the graph of the secant, that's the reciprocal of the cosine. And you're going to have problems here when the denominator is 0. So let's think about that in terms of the graph. Where could the denominator equal 0? When does cosine of x equal 0? There's actually kind of a pattern to this, and I would suggest that you memorize these two patterns. Where does cosine equal 0 and where does sine equal 0? So you should be able to see it on the graph, and if it's not clear enough, then I don't know, maybe click this button right here. Oops, hang on a second. Let's see. Let me do something here real quick. There we go. All right, let me put it back here. There. So there's where the cosine is 0. You can see it. It's at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. Can anyone predict what would be the next place where cosine is 0?
9 pi over 2.
9 pi over 2. How about to the left here? Cosine of pi over 2, negative pi over 2, negative 3 pi over 2. What will be the negative 5 pi over 2. So the cosine of x is equal to 0 at odd multiples of pi over 2. So that's worth writing down here because that's where the secant function is going to have problems. So cosine of x equals 0 when x equals, now I got to characterize an odd number. So it's going to be an odd multiple of pi over 2. If I just did 2 times n, where n is some integer, then okay, that'd be fine, but that's always going to give me an even number. How do you go from an even number to an odd number?
Plus 1.
You add 1. So 2n plus 1, that's going to be the form of your odd multiples of pi over 2. And that's going to be where you're going to have the vertical asymptotes for this graph. So let's actually start to see where this, what this graph of the cosecant is going to look like. And we can do that kind of slowly, especially if you're following along with Desmos. So let's scroll down a little bit, and I'm going to turn on this graph. Now, unlike your graphing calculator, no, not that one. Where is it? Where is it? Where to go? Where to go? Where to go? Ah. Oh. Let's take this slider bar and bring it back over here to a equals negative 3 pi. And then turn on this graph. There we go. Unlike your graphing calculator, Desmos actually does understand secant. You can type in SEX or SEC of x, and it'll understand that that's the secant. On your graphing calculator, there's no secant button. There's no secant function. If you want the secant, you have to type 1 over cosine of x. Just no way around it, even for me. Now, a lot of you might be tempted to say, oh, but wait, there's this button right here. It's cosine to the negative 1. That's not the secant or cosecant over here. It's something different that we're going to see in chapter 3. So with this button on and with this over to the left, let's scroll and start getting this pattern. And it's kind of cool. Now, you can see that when you take the reciprocal of 1, you're going to get 1. But as the value of the cosine falls off and you're dividing 1 by some smaller number, the quotient's going to get bigger and bigger and bigger and bigger until it reaches up towards positive infinity. Now that's as long as you're to the left of pi over 2. Once you cross pi over 2, then the secant's going to be negative because the denominator is going to be negative. So that's why you have this funny kind of cup shape here. And on and on and on. Now, if you want to get rid of the cosine graph, that's fine. We can do that. We can shut that off. What's left here is your graph of the secant. So, nice, nice. One of the features you can kind of see that's not actually going to show up on your graph on purpose is the graph has these vertical asymptotes. So let me click this button down here, and those orange lines are the vertical asymptotes. Your graph is the stuff in between those vertical asymptotes. Now on the handout that I gave you, once you have the graph of the cosine, then getting the graph of the cosecant is not too hard. The only thing I'm really going to want is kind of a cup shape drawn between these vertical asymptotes to the right height. Now the height here is going to be where the top of the corresponding cosine function is. So the height's going to be up to -1 and then down here to 1. Your graph should kind of get close to, but not quite touch the vertical asymptotes. If they accidentally touch it a little bit, that's fine. Just make sure you don't ricochet off of it and come back in on itself. This is one period of the graph of the secant. So period equals 2 pi. After this, the graph's going to repeat itself. And you can see that in this next little part here. And I'm going to draw that in a different color here just to make it clear. But the graph's repeating itself here, and here, and here, and forever in either direction. So the secant gets its period from the graph of the cosine. Cosine is periodic with period 2 pi. Same thing with the secant. So I think that does it for our little secant exposition here on Desmos. I don't think there's anything more. There is one more thing that I could do, and that is I could label or be a little bit more emphatic about where these minimums and maximums are. So let me just shut off this because the graph's getting a little too busy. Let's see, anything else? There we go. So these points here, that's where the graph's going to have its minimum or maximum. So in this case, that minimum or maximum is going to be 1 or -1. There's nothing in between here. If you were to look at the range of this graph, ooh, I know that's going back to college algebra. Help me out. The range is what? Which coordinate?
The y-coordinate, so -infinity to infinity.
Close. Negative to infinity, but there's a gap here, right?
Yeah, you can start at -1 and then you need 1 infinity.
Exactly. So let me write that down. The range for this graph would be -infinity to -1 union 1 to infinity. That's exactly what I was going to ask next. Brackets or parentheses. You're going to have brackets because the function actually does get up to 1 and does get down to -1. Nice. This is the graph of your sine function. So we're going to graph the cosine function, or excuse me, the cosecant next. To understand the graph of the cosecant, it's best to understand where the sine function is equal to 0. So let's see if we can't do that. So let's see, this is going to be y equals cosecant of x. Cosecant, of course, is 1 over the sine. I want to know, where does sine of x equal 0? Well, you can kind of see it here on this graph. And even though I've got it labeled on the x-axis, it doesn't show up very good because of the intercepts of this graph. Kind of obscure that. So these are the points where the sine function actually crosses the x-axis. And there's a pattern to it. You've got at pi, 2 pi, -pi, negative 2 pi. In general, where do you think the sine is equal to 0?
At pi n.
Yeah, at multiples of pi. So when x equals some multiple of pi. Now here, up here, and up here, I'm assuming that n is an integer. Numbers like 1, 2, 3, 4, 5, or negative 1, negative 2, negative 3, negative 4, negative 5, etc. So n is an integer. But these two little pieces of information, I strongly suggest that you keep these things in a special place, maybe where you put all your identities. That way you can look back at them. So this one and this one, where the cosine is equal to 0 and where the sine is equal to 0. Those are going to come back at us a lot in this course. Now the rest of this is going to follow kind of the same pattern that the secant did. That is, you're going to have that cup shape facing up and that cup shape facing down. So let's see if we can't fill in a couple more of these things. So from here, which way should I draw a cup? Should I draw it facing down or facing up? Which way? What do you think?
Up.
Yeah, it's always going to face in the direction that this kind of points, or maybe the opposite direction, depending on how you want to think of it. So there, and then this one's going to be down. But once you have the graph of the sine or cosine that corresponds to your function, I mean, the rest of it is just kind of filling in these cup shapes. Now, on a test, I don't want or need to see the graph of the associated sine or cosine function. That's okay. But what I will be judging you on is this. Do you have your asymptotes written in the right place? And does the function go high enough or low enough? So something like that. Its range is going to be the same thing as it was for the graph of this secant. And let's look at this one. So here's your graph of the sine function. And kind of like what we did a moment ago, I'm just going to drag this slowly. You can kind of see what's forming this pattern. Right here, the graph of the sine passes through 0. So that's where you're going to have a vertical asymptote. You're going to have another vertical asymptote here, and here, and here, etc. Everywhere that this graph passes 0, you're going to get a vertical asymptote. In fact, if you wanted to, you could turn those vertical asymptotes on right here. So there's the rest of this. Nice. But let me do a little something else here. Let me get rid of this and also get rid of our sine function. In front of this, you might notice that I have a coefficient, b. I want you to think what's going to happen when I change the value of b. What happens if I change it from, 1, which is where it's at now, to 2, or to 3, or to 0.5? What do you think is going to happen? What's that?
I'll make the gap bigger.
Excellent. It's going to make the gap bigger. So, ready? Ooh, that's pretty cool. Wow. It's like a set of teeth chomping down on dinner. All right. Now, when you do move this, let's take a look here. When I have a coefficient of b is 3, then look, the bottom of this is 3 and the top is to -3. That's something I'll be judging your graphs on, is where do those go in terms of up and down. Let's see. And I guess, like I said, the other thing is that I'm going to want to see the correct vertical asymptotes. Those should be there. Those aren't affected by that value of b. If b is less than 1, then this graph's going to get kind of really close to the x-axis. And if b was negative, it would flip itself around the x-axis. All right, so that's kind of a good feel for some of the things that can affect the graph of your secant or cosecant. Let's start graphing some of these things in particular. and seeing, getting comfortable with what I expect. For those of you who are here, have a copy of the handout. Those of you who are at home, I hope that you printed out this version of the handout. And we're going to want to look at 2 secant of x. Well, I've kind of already helped you out a lot on this. And that is, I've got some vertical lines here that are drawn. But on an exam, I'd probably ask you to label where those vertical lines are. And in fact, on the exam, what I might do is just give you an x-axis with tick marks, but no labels. So you have to label your own x-axis. Let's see if we can't figure out where this is actually going to have vertical asymptotes. Remember, the secant is really 1 over the cosine. So another way I could write that is 2 times 1 over the cosine. Now, how many people have committed to memory yet? Where's the cosine equal to 0?
2n plus 1 times pi over 2.
Perfect. So let me write a little table over here. N and 2n plus 1 over 2 times pi. And I'm going to plug in a few values here. 0, 1, 2, and then maybe -1, just for giggles. Let's start with a 0. If I plug in a 0 for n, that's going to leave me with 1/2 times pi, or better yet, pi over 2. If I plug in a 1 for n, what's that going to give me?
3 pi over 2.
3 pi over 2. Someone else. Plug in a 2. 2 times 2 is 4, plus 1 is 5. 5 pi over 2. And how about a -1? What do I get when I plug in a -1?
Negative pi over 2.
Well done, thank you. Negative pi over 2. Those are going to be your asymptotes. So let me label those. You've got pi over 2 here, 3 pi over 2, negative pi over 2. Anyone want to guess what this one would be? It's going to be the next odd number down. Olfat? What would that one be?
-3 pi over 2.
Awesome, -3 pi over 2. Those are your vertical asymptotes. Actually, I probably should put x equals on all of these, because that's going to make it a vertical equation rather than just a point. Now, the last thing I need to do is I need to figure out, well, is that I'm going to have a cup shape facing up or a cup shape facing down there? And if so, how far down it's going to go. So a couple ways you could do this. One easy way would just be by plotting one simple test point. Let's pick a point right in between, exactly in between 2 of these vertical asymptotes, like x equals 0. If I put in x equals 0, where's that point going to be? So if I actually was to plot x and y, 0 for x would go with what for y? Well, it's 1 over cosine of 0. Cosine of 0, what's the cosine of 0 equal?
1.
1. So it's going to be 2 times 1, or 2. So that point has to be there. What does that tell me about the shape of my graph at that point? Yes, exactly. I have a cup shape that has to face up. This is the bottom of that cup shape. It's going to face up from here. So it's going to look like that. In the next part of this over, between these next 2 vertical asymptotes, I'm going to have a cup shape. But what's the difference in the next kind of aisle here, if you'd like to call it that?
It's going to be concave down.
It's going to be, yeah, nice word, concave down. It's going to face down here. Mitchell, how high should I draw that cup? Where should it get to in terms of a maximum?
2.
Yeah, should get to 2. -2, yeah, there you go, -2. So there's our maximum there. And then a cup shape facing down. That's one period of the graph. So if I ask you to draw 2 periods, you're just gonna repeat that shape. It's gonna be like this. And then, and this isn't so good. There. You know, these should be going down to, 2 and -2 respectively. And then that pattern continues. I doubt I would ask you to draw more than 2 periods of that graph. Olfat?
How did you get 2 again for the x, for the y?
I put in x equals 0. So that goes into 2 secant of x, or 2 times 1 over the cosine of x. So Olfat, help me out. What's the cosine of 0? Let's go back to this graph. What's the cosine of 0? It's your x coordinate, so it's 1. So if I put in a 0, here I get 1 over 1, which is 1, times 2. That gave me the 2. So I knew that this point had to be on the graph at 0 and 2. So that means the graph is facing up here, and then I know from just what we've covered that the shape is going to alternate above and below the x-axis in these different little kind of corrals created by the vertical asymptotes. All right? Does that make sense?
Yeah.
Okay, good. Yes?
We can skip the table part if we just know the formula.
Yeah, I mean, basically, this maximum height, or excuse me, this maximum height and this minimum height are going to be exactly the same as this coefficient. So you can kind of look at that and say, oh, 2 and -2.
It's the same like points as just regular cosine, right? And it's just graphical because it's not necessarily all the points, but the apex of each.
The apex here is going to match the apex of the sine or cosine function from which that comes. Right here and right here. So these maximums and minimums are going to match the minimums and maximums of the associated secant or cosecant function. Yes?
How did you find the x coordinate of the second minimum?
This one? Oh, this one? Or this one?
This one over, like, yeah, that one works.
Oh, it's just parallel. It's just pick this up and move it over. It's the exact same shape.
Point.
What's that?
Like, how would you find that exact point?
It's going to be in the middle of these two here. So if you're looking at this and going, well, middle of what? The next line over here would have to be x equals -5 pi over 2. And so now you got to figure out, well, what's in between -5 pi over 2 and -3 pi over 2. So what's in between would be like the middle or the average. So let's take a quick look at what the average would be. Now, it might not be terribly pretty, but when you find the average of two things, what do?
Divided by 2.
Add them up and then divide by 2, right? So I want to add -3 pi over 2 plus -5 pi over 2. Add those and divide by 2. The cool thing is that these have common denominators, right? So I get -8 pi over 2. Let's simplify this part first. What's -8 pi over 2 going to simplify down to? -4 pi over 2, which simplifies to -2 pi. So that would be the exact coordinates of this point. So good question. That'd be -2 pi and 2 would be the exact coordinates of that point. If you actually looked at the graph real closely, I'm amazed that the font is crisp enough at this level of zoom, but you can see it's a little bit past 6. And 2 pi is about 6.28. So yeah, it makes sense. Worked out pretty good. Good question. Thank you. Anything else? How about my zoomers? Let me just kind of fan out the view that I've got here. Looking okay on that one? Can I get a thumbs up from my Zoomers? A few people, I'd appreciate you flipping on your cameras. Thank you. Shay, good on that? Hang on a second. I got people muted here. All right, one more time, Shay. You're muted now. I had you muted. Yeah, gotcha. Oh, the average there? Yeah. So you add up the 2 points and divide by 2. And when I added those 2 points, let's just focus in on the numerator for a second. They had a common denominator. So I added the numerators, -3 and -5 give me -8. Still divided by 2. 2 goes into 8 4 times. So this is just -4 pi over 2. And 2 goes in there twice, leaving me with -2 pi. All right, awesome. Let's keep going. Let's try another one down here. Cosecant, or 0.5 times the cosecant of 2x. Now here's where you're going to start earning your money and start earning the points on an exam. This one's going to take a little bit more work. One way you could write that is 1/2 times 1 over what? What function is going to go in the denominator here? Sine of 2x. We're going to have problems where sine of 2x is equal to 0. It's not going to be defined, so we're going to have to do a little bit of work. So let's figure out, where is sine of 2x equal to 0? Okay. Well, in general, sine of x equals 0 when what? What happens? When x equals n times pi. Well, I don't have sine of x, I got sine of 2x. So I'm going to solve, where does 2x equal n times pi? I want to solve that for x. How am I going to get that? How am I going to solve that for x? Divide by 2. X equals n pi divided by 2. And that's it. That's where your graph should have vertical asymptotes. Now, what do those points look like? Well, let's graph a few. I'm going to plug in values of n and get values of x. So I'm going to plug in values like 0, 1, and 2, -1, and -2. Remember, n is an integer. So what values would that give me here? Let's start with n equal 2. What would I get? Pi. What about if n equals 1? 1, 2. Pi over 2. I'll tell you what, I'll help you out here so you don't have to grab your calculators. If n equals 0, so does x. All right, so we're good there. And then -pi over 2, and then -pi. Those are going to be your vertical asymptotes. Let's see that that's true. All right. So on all of these, I'm going to want you to label your axes, your asymptotes. So I'm going to have x equal pi over 2, x equal pi. The next one, if you wanted it, would be x equals 3 pi over 2, and so on. This is x equals 0, x equals -pi over 2, x equals -pi. Now there's one last thing that I've got to do here, and that is I've got to figure out, well, Is it a cup shape facing up or a cup shape facing down in these intervals? How high or how low do they go? So you can pick a point, any point you want in these intervals and graph it. Now, generally speaking, these midpoints are going to be easier to work with. So what's halfway between, say, 0 and pi over 2? Pi over 4. So x and y, 0, oh, not 0, how about pi over 4? Sorry. Pi over 4. Sine of pi over 4, or sine of 2 times pi over 4 is going to be sine of, well, let's see, that'll simplify, right? Pi over 2. Somebody help me out. What's sine of pi over 2 going to be? 1. So that much is 1. And I guess I probably should have plotted 1/2 of that, right? So pi over 4 gets me 1/2. Now where's the 1/2 coming from? If you remember, our cosecant function has a 1/2 in front of it. So what's 1/2 times there? Gives me pi over 4 and 1/2. The bottom line, and you can do this on a calculator, you don't necessarily have to figure it out this way, but bottom line is that I've got a point here. What's that telling me about the graph in this interval? Got a cup shape that faces up. There. And another one that's going to face down. And that's one period of the graph. If you're asked to graph 2 periods, and likely it will be true that you will, the next one's going to be facing down here. And then up here, let's just put that in the middle. There. So the things that I'm going to grade you on the most are how high does this go and where are these vertical asymptotes. That's what I want you to get for me. How are we doing on this last one? These starting to make a little bit more sense there?
Can I see the table on the left again,
This one?
please?
Or
Yeah, that one.
this one? Okay. So the idea with these tables is to figure out where your vertical asymptotes are. And once you've got that, that's a good chunk of the graph. Good there?
Yeah, thank you.
Okay. Please. Oh, well, they're gonna alternate, right? So this one is up, this one's down, this one's up, this one's down, so that's, so it's just gonna keep on following that pattern. Yeah. Now, let's take a quick look at it on the graphing calculator. As much as I love Desmos, and believe me, I use Desmos a ton, chances are moving forward, you're not gonna have a calc instructor that's gonna say, oh, well, just do this on Desmos. So let's get comfortable doing this on a graphing calculator and making sure that our graphs match what we see. First thing I see I gotta change is the degree. I wanna make that radian mode, so let me change that. As far as the equation is concerned, I gotta make some changes there too, so let me clear out these old equations. And there's a couple ways you can input this graph. Now typically speaking, it probably won't be written the way I wrote it. You'll probably see it written as 1/2 times the cosecant of 2x. And you've got a couple choices. Either you can write it as 1/2 times 1 over sine of 2x, or you could put a 0.5 in the numerator, or you could put the 0.5 next to 1 over, no, you put the 0.5, let's see, we got the 0.5 here. What else could I do? I could do 0.5 over sine of 2x. So there's a lot of ways you can input this. I think I'm going to do it this way, but I've got to be careful when I input that into my graphing calculator because I've got to have parentheses around that whole denominator. So let's take a look at that. It's going to be 1 divided by parenthesis 2 sine of 2x. First parenthesis closes off the sine, second parenthesis closes off the denominator. Now, if you're not really keen on that, then the other possibility for you would be if you hit the alpha key, then the y equals key. That first option there gives you the ability to input a fraction, kind of like the way I might write it. So I'll put 0.5 in the numerator and sine of 2x in the denominator. Close parenthesis, and we're good. Both of these will give you the same graph. It's just whatever is comfortable for you inputting things. Now, usually you face kind of a big question. It's like, well, where am I going to draw my graph? What's the window? And let me give you a little bit of a hint. You don't have to think about the window. You've got a window suggested for you right here. Just copy these dimensions. That way, your graph will match mine a lot better. So that means on the x-axis, I want to go from, say, negative 2 pi to 2 pi. And on the y-axis, say, negative 1.2 to 1.2, something like that. So let's try those. So let's go up to the window. Let me clear out these. I'm going to type in negative 2 second up arrow. That's going to be negative 2 pi. Now the nice thing about that is it puts pi in there as a symbol. The bad thing about that is as soon as I hit enter, it's going to replace it by the decimal value. Whoops. Oh well. I don't know why they don't just leave it as negative 2 pi. And up here to 2 pi. I like going to negative 2 pi and 2 pi because a lot of times those are nice even multiples and your graph works out nice there. Let's leave x scale as to 1 for the moment. On the y-axis, I want to go from negative 1.2 to 1.2. And I'm just getting that from the graph that we had there. Once you have all these settings, you should be able to hit the graph key and get something like this. All right. And the reason that it switched from blue to red is because I graphed it twice. I don't need to graph it twice. I'll just shut this one off. You can shut off a graph by pressing the enter key with your cursor over the equal sign. Notice the difference in these two. Okay, so I got plenty of graphs here, but you know, there's something I can do to make this a little bit more helpful in terms of the tick marks here. Now, the tick marks here are every unit, but you know, for this graph, we're not really thinking in units of 1 or 2 or stuff like that. It'd be nice if the units were in something a little bit more even relative to our graph. So a good trick for you would be to let the scale be some unit of pi, multiple of pi. So second pi divided by 2. And now the tick marks should match your vertical asymptotes. So look at that, beautiful. Now you can see, oh yeah, there's a tick mark there at pi over 2. Yeah, there's a vertical asymptote there. 2 times pi over 2, oh well, that's pi. There's another tick mark there. That's another vertical asymptote. So you can easily see where those vertical asymptotes are based on your graph. And then you can easily double check yourself on your graphing calculator on an exam. I strongly encourage that. Let me pause. I threw a lot of stuff at you there. If you have some something about the graph that maybe I went over a little too fast, you want to see a setting or something like that, now's a good time to speak up. Get some help. Doing okay? How about my Zoomers? Can I get a thumbs up? All right. All right. People here? Doing all right?
This whole thing is in one of your videos.
You know, I'm making a video right now,
Oh.
and hopefully if it comes out, then I'll post it to YouTube. But yeah, I mean, these are good tricks. I would suggest you try and pick up a few of them, especially, you know, the one good trick that I mentioned here was the spacing. You know, put X scale as pi over 2. That way it makes it easier to look at your graph. I mean, there's nothing wrong with having X scale equal to 1, but then when you look at your graph, you're like, well, where's that asymptote? It's like 1 and change. It's harder to think about that and say, oh, well, you know, pi over 2, let's say that's 1.57, and yeah, maybe that's right. You know, but then you're just kind of guessing. You know, a little bit past 3, oh, maybe that's pi. It's a lot more user-friendly of a graph to have this in terms of units of pi. So that'd be my big suggestion here. And as far as the other settings on the graph or the window, that came just by looking at this one right here. That's all we did. So, all right, let's keep going. Let's try some more. Let's try -3 cosecant of pi x over 2. This one actually works out pretty nice, even though it might not look like it. It does actually work out pretty nice. So, were there any more questions on this one before I move on? Doing okay there? All right. Let me do this. We're going to need to work with this one a little bit to figure out where the vertical asymptotes are. On your exam, which is going to be 2 weeks from today, expect probably tick marks here, but certainly I won't be drawing the vertical asymptotes for you, and I might not even label it for you, or maybe if I label it, maybe I'll label it in units of pi. We'll see how it goes. Let's see. Y equals -3 cosecant of pi x over 2. Now I can write that a couple ways. I can write that as -3 over the sine of pi x over 2. And that's good. Looking good there. Let's see what I can do with this. I want to know where's the denominator equals 0. So that'd be where does sine of pi x over 2 equal 0? Well, I know that sine of x equals 0 when what? What's x looking like when sine of x equals 0? Yeah, thank you. N times pi. So basically, this is going to equal 0 when pi x over 2 equals n times pi. Now, let's solve for this kind of slowly and methodically. A lot of people, when they first look at this, are going to see fractions and go, ugh, I hate fractions. That's okay. You don't have to like them. We do have to work with them, at least to a point. And the point that I would make is that we're only going to work with them as long as I need to, as long as it takes to get rid of them. What can I do to get rid of the fraction here?
Times by 2.
Multiply both sides by 2. Perfect. Thank you. So let's multiply both sides by 2. Here by 2. Here by 2. On the left-hand side, I'm going to get pi x. On the right-hand side, I get 2n pi. I haven't quite solved for x yet, though. What do I got to do to solve for x? Divide by pi. Thank you. What's left when I divide by pi? 2n. And ooh, this is pretty cool. Take a look at this. Let me write my little chart here. -2, -1, 0, 1, and 2. What are my values of x? wow, that's pretty nice, right? So basically it's gonna be multiples of 2. So that's nice. Let's look back at our handout and you see that, yeah, indeed, oh, wait a minute. No. Yeah, you see that I screwed up the graph here, didn't I? Because I have these at odd multiples of pi, or odd multiples rather than even multiples. I think I must have given the asymptotes for the graph of the secant as opposed to the cosecant. All right, my bad. So let's take a look at what we can do in terms of graphing this the right way. On the back of your handout, I think it was on the back of your handout, I've got a couple extra graphs. So I'm gonna bail and go to one of the extra graphs here. So let's do y equals -3 cosecant pi x over 2. And I'm going to start by drawing, a couple vertical asymptotes, just enough to give me a general sense of this graph. So I'm going to have them at 2. Let's see. Let's start with a -2. And then a 2. Now, kind of what's hidden here is something I didn't draw. This doesn't show up very well, but I will draw it. There's actually an asymptote right here at 0. 1, 2, 3. I need one more. We'll do 4. That way I can graph 2 periods. It's up to you how you want to figure out which way it faces. But no matter which way it faces, it's going to go down to a low of 3 or up to a high of -3. We just got to figure out where it is in this pattern in between. Now, maybe it's not a bad idea to try and graph this again. Try and figure out what its graph looks like, maybe up here, and then we'll draw it on our sheet. So you got a couple ways you can put this in. I'm just going to write it as 3 divided by sine of pi times x.
Professor Jeff is -3.
Oh, thank you. Thank you so much. Yeah, that should be a negative out in front. Here's another little trick for you. 2 of them. If you hit the second key, then the arrow key, it'll take you to, one end of the line or the other. So that's nice. I don't have to scroll as much. The other little trick is if I made a little mistake here, like I forgot to insert a negative, you can insert a negative by hitting the second key, then the insert key. Now just type whatever it is you need. So there's my -3. And I'll clear this one out. As far as the graph is concerned, let me look back at my sheet. I really only need to see things between -2 and say 6 on the x-axis and maybe -5 to 5 on the y-axis. So that's what I'm going to choose for my window. The other nice and user-friendly thing about this is that the tick marks are at, or the asymptotes are at even numbers. So I'll just put in a 1 there. And then I said -5 to 5 should work out pretty good. Keep in mind, if this doesn't give you a graph that you like, it costs nothing to go back and change it. Change these window settings. So some people get a little too obsessed about getting it perfect the first time. And that looks pretty good. To be honest, and to be a little bit self-critical, maybe I should have gone -6 to 6. Just see a little bit more of that shape. And that looks okay. We're getting the important information that we need. Oh, you know what? I probably should have done -2 to 6. That'll match the graph that I've got. There we go. The important information that I needed is this right here. I needed to see where does this bottom out. And to the left of the y-axis, it goes down to right here. Right there. Then to the right of the y-axis, it's going to go here. And then so on. So I'll draw these points. And I'll draw on those cup shapes up and down to finish off my graph. So there, 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 and there. So the equations here are x equal -2, x equals 0, x equal 2, and x equal 4. On the test, when I ask you to label your asymptotes, these equations in black, that's what I'm looking to see. And I'm not gonna really care if these are perfect or not. I mean, just as long as you have the general shape. If I wanted perfect, I'd be doing this on a computer or graphing calculator or Desmos or something like that. I just wanna see that you have the general shape and you can find where the asymptotes are, okay? All right, comments or questions on those? All right, we're gonna take a little break here. We'll come back and we'll work on some of the other functions, the cotangent and the tangent.